So if we look at number 1, here should be in your folder probably, Tiana. Number 1 says sketch a graph for each situation and tell whether the graph is continuous or discrete. So, number 1, a girl was walking home at a steady pace, then she stopped to talk to a friend. After her friend left, she jogged the rest of the way home. So she's walking at a steady pace. What's our graph going to look like?
Like a straight
line. Yeah. Perfect. Straight line because it's going to be constant. Okay, if she then stops to talk to a friend, what's going to happen? It's going to drop, okay, all the way down to 0. And then she jogs the rest of the way home. So then what? It goes up. Very good. So your graph should look something like this.
Well, mine looks like this.
That'll work. So then what type of graph is this? Continuous or discrete? Continuous. Very good. Alright, if we look at number 2, a ball is dropped from a second-story window and bounces to the stop on a patio below. So, it's going to be up here, and then we're going to go down, and we're going to hit here, and then we're going to bounce back up, and it's going to keep doing that until it stops, it says. It bounces to a stop. So your graph should look something like that. What type of graph is that? Continuous.
I didn't see it say bounces to stop.
Alright, if we look at number 3, write a possible situation for the graph. Who has a possible situation that they wrote for number 3 that they want to share?
They have
babies, or they add 2 fish a week. Very good. So, fish have babies. Or you could say, like, you bought new fish every 2 weeks, or something like that, or every week. Yep.
I put every 2 weeks.
That'll work. Okay, so something along those lines would work. For number 4, who's got a situation they want to share for number 4? Perfect. Okay, so boy sleds downhill, climbs back uphill, and takes a break. Anything that has to do with the height changing, so we could talk about maybe like an airplane was flying and then did a nosedive and then recovered or something like that. Okay. You could say that. Anything that has to do with height over time. Or a submarine went way deeper into the ocean and then came back to the surface.
It's like your head pounds like this girl, I cannot handle girl. You just don't know, she's sitting next to me like in a bag and I was like, oh my god. This one has a really sexist. And we went, it looks like that. It looks like the clock is down deep down the road. I'll show you after school, but it'll tell you how many feet we went under. And we went 117 feet under.
Holy moly. It's pretty deep. I would not like that. Alright. Number 5 says express each relation as a table, a graph, and a mapping diagram. Give the domain and range of each relation. Explain whether the relation is a function. So we've got lots to do on this problem. So we're going to start with doing a table, map, and a graph.
Please go to the subjective zero. Alex Boyle, zero charging, and gallery. Brooke Guide, River Guide, by Americans, Wild Shipwright, Sarah Hopi, by Alg1. Alice Bordeaux, Joan Charging, Annabelle Dubuque, Brooke, River Dining, Brian Harrison, Mark Embrace, Trilogy, Viola Lewis, please go to the suggestions.
Okay, so if we look at then number 5, we'll give our x and y table, so let's start with that. So my first value is always my x, my second value is always my y. So I'm going to have negative 1, 0, 0, 1, and 2, 1 for my table. Okay, then if I go to make my mapping diagram, my x values are negative 1, 0, and 2. My y values are 0 and 1. I do not put the 1 twice. You only put the 1 time. Okay? And to finish that mapping diagram, we have to map those numbers to each other. So I know that negative 1 maps to 0, 0 maps to 1, and 2 also maps to 1. Okay? And the last part of that problem was graphing. So negative 1, 0, 0, 1, and 2, 1. Okay, do I connect my points? No. Okay. The next part of that problem asks you to find your domain and your range. Domain refers to what values? Your x or your y? Your x's. Okay, so what are my x values? Okay, negative 1, 0, 2. What are my range values? 0, 1, and 1, so do 0 and 1. We don't have to write them twice. Okay, and then the last thing it asks us to do is decide whether or not this is a function. So if we look just at our x values on our mapping diagram, are there any of those x values that have more than one arrow coming out of them?
Yes. Oh, no.
No, this one only has 1, 0 only has 1, and 2 only has 1. So this is a function because it only has one arrow coming out of each of the x's. Just like on like a vertical line test, if it only crosses once, it's a function, more than once not. So more than one arrow is not a function. Okay, if I look at number 6, I'm going to make a table, a map, and a graph. Okay, so let's start with our table. What are my x values? Okay, and what about my y values? Perfect, so negative 2, negative 1, negative 1, 1, 2, 3, 3, 4. So then I do the same thing over here. Negative 2, negative 1, 2, and 3. Negative 1, 1, 3, and 4. And negative 2 maps to negative 1. Negative 1 maps to 1. 2 maps to 3. 3 maps to 4. Okay. Then if I graph that, negative 2, negative 1 would be back here. Negative 1, 1 goes back 1, up 1. 2, 3 over 2, up 3. And 3, 4 over 3, up 4. So we'd get a graph that looks something like that. So then the next thing I have to do is figure out my domain and my range. Okay, so what's my domain? Okay, perfect. Negative 2, negative 1, 2, and 3. Those are my x values from my mapping diagram. What about my range? Perfect. Negative 1, 1, 3, and 4. Those are my values, my y values from my mapping diagram. So the last thing I look at is whether or not this is a function. So looking at my x column of my mapping diagram, is there any x value that has more than one arrow? Nope. So is this a function? Perfect. Okay, we feeling good about that, or we want to do number 7?
I'm good.
Okay, so we'll skip 7 for now. Okay. Alright, so number 8. Determine the relationship between the x and y values. No, sorry, that's not, no, we have to do something different. Sorry, I thought you were talking about here. No, we have to do something different for this one. You can leave that though. Okay, so to determine the relationship between my x and y values, the first thing I have to do is I have to try adding and subtracting. You remember when we did that? So we're taking our x value, we're going to do something to that x value to make it be our y value. So if I look at my first x value, 1, I need to figure out what I need to do to 1 to make it equal that negative 6. So what do I need to add or subtract from 1?
Oh wait, 7.
Perfect, subtract 7. So that's what I'm going to attempt to make my pattern.
Oh,
Okay.
I remember this.
So then 2 minus 7 gives me
Wait.
negative 5, which is what I wanted. Okay. What about 3 minus 7? Negative 4, which is what I wanted. And then 4 minus 7 gives me negative 3, which is what I wanted. So I know that my pattern is subtracting 7 because it worked for everything. So then my function that it asks me to write is x minus 7 equals y. Yes. I can most definitely leave that up there for a bit.
I don't know how to do this, and now I know how to show this.
Well, good.
I didn't know how to do this.
That's why we review, so we know what to study.
Is there a test tomorrow?
Yep. All right, everybody got that? Yes? Okay.
Mr. Eno, please come to the high school office. Mr. Eno.
All right, if I look at number 9, I'm going to do the same thing. So I'm first going to try adding and subtracting. So I know that I'm going to take my x value, do something to it to make it be my y value. So if I look at 1, what do I need to do to 1 to make it be 9? With adding and subtracting.
What?
Okay, so let's see if that pattern works. So 2 plus 8 gives me
Oh wait,
10. But what I wanted was 18, right? So that doesn't work. So adding and subtracting doesn't work. So we're going to try multiplying and dividing. Okay, so I'm going to take my x value, do something to that x value to make it be my y value. So if I do my 1 again, 1 to make it be 9, what do I need to do to 1 to make it be 9? Times 9. Okay, so let's see if that pattern works. 2 times 9 gives me 18, which is what we wanted. 3 times 9 gives me 27, which is what we wanted. 4 times 9 gives me 36, which is what we wanted. So I know my pattern is multiplying by 9. So I know that my function is x times 9 equals y. You could also write it as 9x equals y. Okay, it means the same thing. Okay, so if I look at number 10, it says identify the independent and dependent variables. Write an equation in function notation. So I know I'm going to look for independent and dependent variables. And I know that function notation is f of x. So I'm going to have some type of function in f of x. Okay, so if I look at number 10, a baker spends $6 on ingredients for each cake he bakes. So we're talking about ingredients and we're talking about cakes. So does the number of cakes depend on your number of ingredients, or does the number of ingredients depend on the number of cakes? Like if I have 0 gallons of milk, how many cakes can I make? 0, right? Nothing. Okay, so then that means that my ingredients depend, or my cakes depend on my ingredients, because I can't make any cakes if I have no ingredients. But I can have 20 cakes that I made, and I still might have no milk, because I already made my cakes, right? So your cakes are your dependent because they depend on you having ingredients. If you have no ingredients, you have no cakes. So then your ingredients are your independent. Okay, and then the next thing we have to write is our function notation. It tells us he spent $6 on ingredients. So, are we going to use addition, subtraction, multiplication, or division for this one? Multiplication, yep. So we're going to multiply. So we're going to take our $6 times our number of ingredients, which we have, which is x. Okay? Or you could write this as just 6x. It doesn't matter. Either one means the same thing. Okay? So 6 times x or 6x. Alright, if I look at number 11, I'm talking about CDs that Tim buys and CDs that Raul buys. Okay. So it says Tim will buy twice as many CDs as Raul. So which one of those is independent? Meaning they can buy as many CDs as they want. Raul, right? He's independent because he gets to shop as much as he wants. Tim, on the other hand, has to buy twice as many CDs as Raul always. Okay? So Tim, the number of CDs Tim buys depends on how many CDs Raul buys first. Okay? And so then if we were going to represent that, we're going to have twice the number of CDs. So 2 times x or just 2x. Alright, so any questions on independent, dependent variables or function notation? Okay. So once we get to number 12, that's when we're going to start graphing. We're going to do quite a few of those graphs, okay? So we're given 4x plus y equals 2, and we're given the domain -2, -1, 1, and 2. First thing I have to do is solve this for y. So how do I get rid of this plus 4x? Minus 4x and minus 4x. So I end up with y equals 2 minus 4x. Okay. Now I can make my table of values using my domain. So my domain was -2, -1, 1, and 2. Okay, and domains are your x's. So if I plug in -2, I get 2 minus 4 times -2. Well, a negative times a negative becomes a positive. So this would become positive. 4 times 2 is 8, and 2 plus 8 is 10. Okay, if I plug in -1, 2 minus 4 times -1. A negative times a negative is a positive. 4 times 1 is 4, so 2 plus 4 is 6. Okay, if I plug in 1, 2 minus 4 times 1. 4 times 1 is 4, and 2 minus 4 is -2. Okay, then if I plug in 2, 2 minus 4 times 2. 4 times 2 is 8. 2 minus 8 is -6.
I got that. Yeah.
Oh, oops. It's probably because you forgot that a negative times a negative would give you a positive. And so you just had like 2 minus 8, and then you ended up with 2. Yeah, I can see that. But, well, at least you got the right numbers, kind of. Just the opposite. Alright, so -2, 10 would be up here. -1, 6 would be back 1 up 6. 1, -2 is over 1 down 2, and 2, -6 is over 2 down 6.
Oh, I had that.
That's what happens when your numbers are switched, your graph ends up being backwards. Alright, so if that's the case, do I connect my points or not?
No.
Nope, if it gives you your domain, you do not connect your points. Okay, so if I look at number 13, we're going to use that same domain on the function 1 minus x squared. So in this case, it's already solved for y, so I can just go ahead and start plugging stuff in. So if I plug in -2, 1 minus -2 squared. Well, minus a negative becomes a positive, and 1 plus 2 is 1 plus 2 is 3. 3 squared is 9. So end up with being 9. So 1 minus negative 1 squared. Minus a negative becomes a positive. 1 plus 1 is 2. 2 squared is 4. I plug in 1. 1 minus 1 squared. 0. And 1 minus 2 squared. 1 minus 2 is negative 1. Negative 1 squared is 1. Perfect. So negative 2 9's back 2 up 9. Negative 1 4 is back 1 up 4. 1 0 is 1 0. And 2 1 is over 2 up 1. Do I connect my points? Nope. Alright. So then we're going to look at somewhere it doesn't give us our domain. So how do I get rid of this positive 3x? Minus 3x. Minus 3x. Perfect. Y equals 1 minus 3x. And we get to make our own domain.
1, 2, 3.
1, 2, and 3. Perfect. Easy domain. So if I plug that in, then I get 1 minus 3 times 1. Well, what's 3 times 1? So 1 minus 3 is negative 2. Perfect. If I plug in 2, 1 minus 3 times 2. 3 times 2 is, and 1 minus 6 is negative 5. And then if I plug in 3, 1 minus 3 times 3 gives me negative 8. Perfect. So I get over 1 down 2, over 2 down 5, and over 3 down 8. Do I connect my points on this one?
No.
Yes. Yep, it doesn't give us a domain, so then we connect our points. Alright, if I look at 15, y equals 2 minus the absolute value of x. It's already solved for y, so I just can go ahead and get started. So what do we want to use for my domain? 0, 1, 2, 3. Okay, we have to use at least 3. We'll use 4 on this one. Alright, so if I plug in 0, I get 2 minus the absolute value of 0. What's the absolute value of 0?
0.
So 2 minus 0 is just 2. If I plug in 1, 2 minus the absolute value of 1. What's the absolute value of 1? What's 2 minus 1?
1.
Okay. If I plug in 2, 2 minus the absolute value of 2. What's the absolute value of 2?
2.
2 minus 2 is
0.
0. And then 2 minus the absolute value of 3. Absolute value of 3 is 3. 2 minus 3 is negative 1. Okay, so then 0, 2 is at 0 up 2. 1, 1 is over 1 up 1. 2, 0 is over 2 up 0. And 3, negative 1 is over 3 down 1. Do I connect these points? Yes. Okay.
Did we have to have 4 or?
Nope, you just have to have 3. Yep, all you have to have is have 3. Alright.
Can we connect them?
Yep. Alright. Last graphing one. What do we want to use for my x's?
1, 2, 3.
Okay. So if I plug in 1, then I get 1 squared minus 6. What's 1 squared?
1.
1 minus 6 is negative 5. If I plug in 2, 2 squared minus 6.
4,
Negative 2. And 3 squared minus 6 is 3. Perfect. So 1, negative 5, so over 1 down 5. 2, negative 2 over 2 down 2. And 3, 3 over 3 up 3. And do I connect them?
Yes.
Very well. Okay. So, any questions on our graphing? No. Okay. we look at number 17, we're going to start making our own scatter plot. So it says graph the scatter plot using the given data, describe the correlation, and illustrated by the scatter plot. Okay, since our years are on top in our table, those are going to be my x values. That's why years are on the bottom. Okay? Since the value is the second set of numbers, it's going to be my vertical axis or my y-axis, so value is going up. Okay, so that's why I set my table that way. I'm just going to put my years starting at 2000 on the bottom. I noticed then that on my graph, I have values of 28, 25, 23, and 20. Okay, so that tells me that my lowest value is 20, and my highest value is 28. So I put my values between 20 and 30 on my graph. Okay, so everyone kind of understand why I made my axis the way I did. Okay, so you can create your own, but this is probably the easiest way. So then if I make 2000 be my first year, I'm at 28, so I go over to 2000 and up to approximately 28. Scatter plots are approximate, remember. So if I go over to 2001, I'm at 25, so I'd go up to approximately 25. 2002, I'm at 23, so I'd go up to approximately 23. And at 2003, I'm at 20, so I just go up to just 20.
Negative.
And it has a negative correlation because it's going down. Very good. Okay, what type of correlation is it if it's going up?
Positive.
And what type of correlation is it if it's all over the place? No correlation. Yep. Negative goes down, positive goes up, and if it's all over the place, then it's no correlation. Okay, since all these ones went down, it's negative. Alright, and then the last part of our test is on arithmetic sequences. So it says determine whether the sequence is arithmetic. If so, find the common differences in the next three terms. So let's start by trying to find my common difference. What do I need to do to get from 20 to 14? Minus 6, and to get from 14 to 8, and from 8 to 2. Okay, is this arithmetic?
Yes.
Why? Because they're all the same. Perfect. And so that's called my common difference. I'm going to label that D. Okay, so then if I keep going with subtracting 6, then I'm going to get negative 4. Negative 4 minus 6 is negative 10, and then negative 16. So my next three terms would be negative 4, negative 10, negative 16. Do we have any questions on that one? Okay. Next up then is the sequence negative 15, negative 12, negative 9, negative 4. So to get from here to here, I'm going to add 3. Okay, and from negative 12 to negative 9, add 3. And from negative 9 to negative 4, add 5. Okay. Very good. Since those are not the same, this is not arithmetic. Okay, we don't find our next three terms because it doesn't have a common difference. So all we put is not arithmetic and we're done on that one. Okay, 2 left. So how do I get from negative 8 to negative 5.5? Perfect, plus 2.5. Okay, and then from negative 5.5 to negative 3. Okay, and from negative 3 to negative 0.5. Okay, so then let's keep going. This is my common difference. It is arithmetic. So I'm going to add 2.5. So negative 0.5 plus 2.5. 2. 2 plus 2.5. 4.5. 4.5 plus 2.5. 7. Okay, so my common difference would be 2.5. My next three terms would be 2, 4.5, and 7. Alright, and the last thing that we're going to look at is your formula for your nth term, and I am going to leave that one on the board. I'm going to rewrite it because somebody messed it up. So a sub n equals a sub 1 plus n minus 1 times d. Okay, so that's going to be on the board for you, so you don't have to memorize that, but it might not be a bad idea. So then what is my a sub 1?
Negative 4.
Negative 4. Your a sub 1 is your first term of your sequence. My first term of my sequence was negative 4. Okay, plus, yep, times 6, perfect. N is the number you're looking for, so we're looking for our 18th term. D is your common difference, which it told us was 6. So now let's just start putting stuff in our calculator. What's 18 minus 1? 17, so I end up with 17 times 6. What's 17 times 6? 102. What's negative 4 plus 102? 98. Perfect. So you should have gotten 98 to be your full number for your 18th term once you were done. You know, can I see? Alright, so does anybody have any questions on this before tomorrow when we take their test? No. Okay.